If you're looking for additional Regents exam info, then jump onto your computer and log on to RegentsReviewNY.net. It's the official website for the series, and it's loaded with test prep resources that are guaranteed to cure those Regents exam blues. Video clips, test-taking tips, exam schedules, and a host of links to other Regents resources. It's all here. And don't forget, all of the programs in the series will be available for streaming on the site once the television broadcast schedules are complete. So what are you waiting for? Increase your chances for a better score on test day. Regents Review 2.0, the next generation of Regents exam prep. Regents Review 2.0 is made possible by New York State Teacher Centers, providing professional development for teachers by teachers. New York State Teachers Centers, a source for teachers and a promise to students. And by NYSIT, representing 600,000 professionals in education and healthcare. And by contributors to your PBS station from viewers like you.
For cluster emphasis number 4, we need to understand the relationship between zeros and factors of polynomials. Here we're asked to use an appropriate procedure to show that x minus 4 is a factor of the function f of x equals 2x cubed minus 5x squared minus 11x minus 4, and then explain your answer. What I like about this problem is it says use an appropriate procedure, so you have choices. I think what they were hoping you would do is know the remainder theorem. If x minus 4 is actually a factor of that function, that means that if you plug 4 in, you'll get 0 back out. That's the quickest way to solve it, and that's my first suggestion. So what you'll want to do is replace x with 4. So we'll find f of 4 equals 2 times 4 cubed minus 5 times 4 squared minus 11 times 4 minus 4. Again, because if it's a factor, 4 minus 4 is 0, we will get 0 back. Now you need to show that work. You need to write in your substitutions, but it's expected you'll use your graphing calculator from there. And I've shown that. So when you do that and you substitute 4 for x and type in your expression, we indeed get 0. You can see that here. So because you get 0, since f of 4 equals 0, then x minus 4 is a factor. That's really the fastest way to do it, and I do think that was the intention of the problem. But it did say use an appropriate procedure, so there are 2 other things you could do. You could also recognize that anytime you see f of x, that's something that can be graphed, and you do graph these a lot in Algebra 2. When you graph that, if x minus 4 is a factor, then x equals 4 will be a 0. So let's look at a graph of that. So here's a graph of our function, f of x, and in fact, when you look carefully at it, it crosses the x-axis at 4, 0. So x equals 4 is a 0, so x minus 4 is a factor. That's the second way you can approach this. The final way you could approach this is with long division. I don't suggest it, but if you are struggling to come up with an answer, you can certainly do that. So let's take our x minus 4 and divide it into our 2x cubed minus 5x squared minus 11x minus 4. And hopefully you remember from elementary school, long division then is just like long division is with polynomials. First we need to decide what I multiply x by to give me 2x cubed. And that is 2x squared. So I multiply 2x squared through x minus 4 and get 2x cubed minus 8x squared. You subtract that entire expression and get the 2x cubes to cancel. That's the whole point. Negative 5x squared minus negative 8x squared is 3x squared. Bring down the 11x, the negative 11x. Now decide what you multiply x by to give you 3x squared. That's positive 3x. 3x times x is 3x squared. 3x times negative 4 is negative 12x. Subtract the entire expression. The 3x squareds cancel. Negative 11x minus negative 12x is positive x. Bring down the minus 4. And x minus 4 times positive 1 gives you x minus 4. Subtract that entire expression, and you're left with a remainder of 0. So again, you can show that x minus 4 is a factor, because when you do long division, you get a remainder of 0. 3 nice ways to proceed through this problem. Long division, graph it and find the 0, or use your remainder theorem, plug in 4 and get 0 back. And all of those are appropriate procedures. Okay.
We're rolling.